electric field intensity. Once again at Basic with teacher course, we are saying electric field intensity. That's the strength. The strength I have, the strength you have, the strength we have. It reminds me of those days when we are young and we'd be in our patriotism club and we'd be singing the songs that would give us strength. That who will build Uganda? And it is me and you. And the song would go. You can sing along with me. It is in Kiswahili. And it would go. Uganda itajengwa na nani vijana. Then you, the youth, us would respond. Uganda itajengwa na sisi wenyewe. Okay, we go. Then we have also the ladies standing. Uganda itajengwa na sisi wenyewe. Uganda itajengwa na sisi wenyewe. Uganda itajengwa na nani vijana. Uganda itajengwa na sisi wenyewe. Uganda itajengwa na nani vijana. Uganda itajengwa na sisi wenyewe. Ayo, sisi wenyewe. Ayo, sisi wenyewe. Ayo. I continue and I come to you. Who is going to build Uganda? That's the question that was in the song. And the reply would be, Uganda is going to be built by we ourselves. Uganda itajengwa na sisi wenyewe. In your capacity. What have you tried? How have you tried to build Uganda? In my own capacity, I started back science education consultant. You understand physics, we apply it. I'm here, giving you power. That is related to the electric field intensity. That is the strength. We have looked at the electric field and we said that is the region around a force, a charge, where a force can be experienced. But then, depending, let's say this is our field. Maybe the charge is here, okay? The force that is experienced here is different from the force that is experienced there, okay? Let's say we have placed one charge of one coulomb, which is positive. The force experienced on this is different from the one experienced on that. And we are saying, depending on where you are, depending on the magnitude of charge that is bringing that force, the intensity will be different. But make sure you raise your intensity in constructing Uganda. It must be built by you and me. It will not be built by another person. This is our time. This is not their time. Uganda will be built by only us. So what is electric field intensity then? It is a force. But that force is not on any charge. It is a force on a charge of positive 1 coulomb. That is to say that electric field intensity is a force on a charge of 1 coulomb, which is positive, pressed at any point in the field. A force on 1 positive coulomb of charge, pressed at any point in that field. That force at that point on 1 positive coulomb of charge, that force is the electric field intensity. That force is the electric field strength. The definition you have got, the understanding you have got. And then after, since it is a force on a charge of +1 coulomb, then it means we have known that a force is Q1, Q2, out of 4 pi epsilon naught r squared, which you normally say is 9 exponent 9, then Q1, Q2 out of r squared. But we are saying that one of the charges is 1. So meaning when I substitute here 1, I don't remain with 1 charge. In short, I can say that electric field intensity is simply the force out of the charge. The force out of the charge, and that one will be 9 exponent 9. Then one charge that has remained, I can leave it as 2, then divide by the distance of separation, which is squared. That is the electric field intensity. This lesson is going to be very nice. I'm telling you, prepare yourself, okay? Then what is the SI unit? Yes, the SI unit, force out of charge. The SI unit of force, SI unit of force is Newton. The SI unit of charge is a coulomb. So Newton divided by Coulomb is a Newton per coulomb. That is the SI unit of electric field intensity. Someone can say also the SI unit can as well be a volt per meter. The SI unit can be a volt per meter, and electric field intensity is a vector quantity, just like the force is a vector quantity. And we don't have to waste time. We are going to begin. We are going to begin and do calculations on electric field intensity. And one, given the charges below, this is point R, this is point Q, this is point P. We are told these are 2 centimeters. These are how many? 5 centimeters. This is 4 microcoulombs. This is -6 microcoulombs. Yes. Find the electric field intensity at P. Find the electric field intensity at P. How do we find the electric field intensity at P? How do we get it? So P is here. So we need to know the force. If there is one positive coulomb of charge here, the force that acts on it. As simple as we calculated the force, we shall calculate this one. So we shall also use the principle of superposition of electric forces. So therefore we shall have the electric field due to this one of 6 equals. By the way, if I try to bring this one this side, does it go there? Yes, because this one is positive, this is negative. It will be attracted. So it will be in that direction. Okay? So it will be in this direction. So as we substitute here is 9 exponent 9. Then the charge is the charge of 6 exponent -6. Then the separation between this and this is 2 centimeters, which when pressed put in meters is 0.02, and that separation must be squared. And when you press on the calculator, you will get 1.35 exponent 8. That is Newton per coulomb. It will also experience another force. Assume that one positive one charge is here. It will experience another force due to this. And this one will be like, we don't support each other. Yes, we don't support each other. So as this one, we assume this one is not there. Now this one is coming this side. This is positive, it is also positive. So this one will be telling it, go away. So it will be experiencing a force in that direction. Okay? So that is a force. The intensity due to this charge of 4 will be in this direction, and this is 9 exponent 9, then 6, then 4 exponent -6. Then the separation between this and this, from here to here is 5, from here to here is 2, so it will be 7 centimeters, which is 0.07 squared. And when that one is done on the calculator, you're supposed to get 7.347 exponent 6 Newton per Coulomb. As usual, we have got them in different directions, so we can get the resultant. This one is towards the right, the other is towards the left, and you can see this one is bigger than this, so you can simply get this and subtract that. So we can say the resultant electric field intensity will be 1.35 exponent 8, then minus 7.347 exponent 6, and when you subtract the two, you get 1.2765 exponent 6 Newton per Coulomb, and you must give the direction, which is towards the left. The direction is towards the left. So by doing so, you have calculated the resultant electric field intensity on that. Really, do you see any complication in science? Don't you see it is really a blessing that you have chosen physics in your life? Just to remind you, without physics, this life does not move. Wherever you stand, it's physics that actually works. Look at the buildings. Even when you are inside and you say, let me go outside, you have to sit on the shade. Look at the clothes that you put on. This YouTube that actually you are studying from, the data that you are using, nobody understands. It is only physics. The electricity, the radios, the television, the aeroplanes, the ferries, any other thing. So, do not be lazy at understanding more in physics as we move on, so that you'll also be part of the Uganda building.